Alright, so we are going to solve this ellipse problem. So we are given an ellipse, and we know it's an ellipse, they tell us that. We know the length of the latus rectum, and we know the coordinates of our two foci. Alright. I've also written down the formulas that we need for this. So here's our general formula for an ellipse. Our length of our latus rectum, it gets a little messy here, but that's 2b squared over a. And I want you to know that c squared is big minus small squared, big squared minus small squared, which we'll talk about soon. Okay. So, the first thing I want to do is plot the points of our foci, or our foci points. So 0, negative 10, I'm going to go by 2s, 2, 4, 2, 4. So 0, 2, 4, 6, 8, 0, negative 10, and 2, 4, 6, 8, 10, 12, negative 10. Okay, I'll put our coordinates. Okay, so if you get stuck on these, or just in general, the first thing I want you to do, if possible, is I want you to find the center. Find the coordinates of the center. That's always a good place to start. Remember that our center is right in the middle of our two foci for ellipses and for hyperbolas. The correct way to do this is to use the midpoint formula, which you can review. I'm just going to look at the graph, and if it's on graph paper, it's easier to see. But here I can tell, since they're on a straight line, that our center must be at 6, negative 10. So that's our center. Okay. The next thing to think about is if you have foci and you have a center, then you should be able to find C. Because remember, the definition of C is the distance between our center and our foci. So our distance here, and again, the correct way, or the official way to do this, is to use the distance formula. But if you can infer it or see it on your graph, then more power to you. So our distance here, C, is equal to 6. So there's 6 units between 6 and 12. So we have C. We haven't used this, well, either of our formulas yet. So the next thing I'd say is find C if possible. And our third step is going to be basically formulas. We're going to try to apply our formulas to solve for what we don't know. And right now we don't know A and we don't know B, which makes it kind of a hard problem. We're missing both. Okay, let's go ahead and grab the length of the latus rectum and plug it into our formula. So we'll say 12.8, which is the length of our latus rectum, equals 2b squared over a. So I've just plugged that in. Let's go ahead and grab this. Okay, quick point. This is important. We know that our major axis always has our foci on it, so our foci are on the major axis, and the major axis is the longer axis. So we don't have one of these ellipses, we have one of these. Does that make sense? Because this distance has to be longer, this axis has to be longer because it's the major. Okay, so that means that a squared is going to be bigger than b squared, or a is going to be bigger than b. So our version of this formula I want you to use is going to be c squared equals a squared minus b squared, because in this case, not always, but in this case, a is bigger than b, so this is the formula we want to use. We already know that c is 6, so I'll go ahead and plug that in. So we'll say 36, because that's just 6 squared, equals a squared minus b squared. Okay, so there's a formula. Here's another formula. So whenever you get to a spot like this in math, I want you to remember that if you have two variables and two equations, so here's one equation, here's two equations. If you have two variables and two equations, then that becomes a system of equations. And if you have the same number of equations as you do variables, then it should be a solvable system. All right. And you have a few ways to solve this. You could do graphically, which sounds like a disaster. You could do elimination, or you could do substitution. I'm going to try substitution. And I'm going to start by taking equation 2 and simplifying it. So let's give that a shot here. Okay, so here's equation 2. So I'm going to multiply both sides by a first. So we have 12.8a equals 2b squared. All right, I just multiplied both sides by a. Now I'll divide both sides by 2, and I'll get 6.4a equals b squared. So there's a formula. And now I'm going to substitute this b squared in there. All right, and I'll grab a new piece of paper to work on that with. So here's some more paper. Okay, so let's grab it at this point. So I have 36 equals a squared, and I'm going to plug in 6.4a, so minus 6.4a. There we go. And now I have 0 equals a squared minus 6.4a minus 36. So I solved this equation, or I put one side equal to 0. And the reason I did that is because I want to use the quadratic formula. The reason I'm using the quadratic formula is because there's some decimals in here, so I don't think factoring or other ways that you know how to solve quadratic equations are going to be very useful here. I'm just going to go ahead and go straight to the quadratic formula. So our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac. Make sure you have that memorized, over 2a. So there's our quadratic formula. So let's try it. So x equals, and here we have negative 6.4 because b is negative, so we're going to have 6.4 plus or minus the square root of 6.4 squared, and I'll grab my calculator for that. I'm going to go ahead and move this out of the way. Okay, so 6.4 squared is 40.96. So 40.96, excuse my phone, minus, I'll do 4ac, so 4 times 1 times c, which is negative 36, over 2 times 1. So I like this top already. I like the discriminant, the part inside of here. I like this already because it's a minus and another minus. So I think this is going to be a plus sign, and we'll have a positive square root, the square root of a positive number, which means a real solution, which is good news. We don't want any imaginary solutions here. That would be sketchy. Okay, so 6.4 plus or minus the square root, and now I'll use my calculator again. So 40.96 minus 4 times 1 times negative 36. 184.96. I'll go ahead and take the square root, and it's a kind of nice number. I'm going to go ahead and scratch this out because I already did it. So 13.6 over 2. There we go. So x equals, and now I'll solve for both of these. So I'll do the plus version first. Okay, and I get 10. That's a nice round number. And now I'm going to do the minus version. I already did the plus one. I'm going to do the minus. So 6.4 minus 13.6. Remember, the plus or minus just means that there's two solutions. One with a plus sign, one with a minus sign. And negative 3.6. Okay, so this is kind of important. Remember that we're solving for a. So back in our equation here, we were solving for a. I'm a little suspicious about a negative a, because conventionally with ellipses and hyperbolas and all these conic sections, you're not going to have negative a's or b's. So because of that, I'm going to go ahead and choose this solution, because I think it's going to be a lot more reliable, because negative seems suspicious to me. All right, so we're almost done here. So we have a equals 10. All it's left to do is solve for b and plug everything in. So I'll use this equation to solve for b. So 36 equals 10 squared, which is 100, minus b squared. So I'm going to subtract 36 from both sides, add b to both sides. So I have b squared equals 64. So b equals 8. Okay. On your test, I want you to check these answers, make sure they work. But for now, let's go ahead and write our final formula, which is x minus, let's see, the x coordinate of our center is 6 squared over 100, which is a squared, plus y minus the y coordinate of our center is minus 10, so it's going to be plus 10 over b squared, which is 64, don't forget your squared here, equals 1. Okay, so there's our final answer. You guys should be okay plotting that.